Alright, here we go, guys. Factoring day 2. Now this factoring today we're going to deal with trinomials when there is a number in front of the x squared term. Okay, that makes things a little bit more difficult sometimes. There are a few different ways of factoring this. One way is just to try to reverse FOIL it and kind of guess and check with the numbers. I think some of you guys have learned some sort of box method. Again, I personally do not care as long as you do it correctly. I do not care what method you use to factor. But one method that I'm going to show you today that I'm going to use is called splitting the middle term. We also call it Batman, as you will see later. But it's basically called splitting the middle term. And this will work every time as long as it's factorable. So, first thing you do when you want to split the middle term is you take the first and the last number, so 2 and 3, and multiply them together. And this would be 6. So 2 times 3 is 6. Now, you're looking for a number that multiplies to 6. You're looking for two numbers that multiply to 6 but add to 7. So we can split up that middle term. Okay? And hopefully you realize that, 6 and 1 multiply to 6 and add to 7. So it's kind of like what you do with the reverse foiling normally. So what you do is you take this 6 and say, and this, like I said, 6 and 1 will add to 6, or multiply to 6 and add to 7. So I'm going to say that this is the 6x and this is 1x. So now we split, basically what we did was we split the 7x into 6x plus 1x. Now we bring down the other terms. And this is 2x squared. And this is a plus 3. The reason why we sometimes call this Batman is it kind of looks like the Batwing symbol when you do it. Alright, so when we get this down here, the next step is we want to factor by grouping. Factor each piece by grouping. So factor by grouping, which we talked about yesterday. So basically take GCF out of each little piece. So for instance, in this first grouping, I can pull out a 2 and an x. So this will be 2x. What's left over is an x plus 3. Over here, you might look at that and go, I can't pull anything out. But in essence, you can pull out a 1 if necessary. Always try, if there's nothing that looks like it could be pulled out, pull out a 1, which just doesn't do anything with the problem. And we get to here. Now, the nice thing about this is we're factoring it, and now remember with grouping, these need to match, and sure enough, these pieces match. So one of my factors is x plus 3, and the other one is the remaining stuff outside, 2x plus 1. So the answer to this problem is x plus 3 times 2x plus 1, and now it is completely factored. Again, some of you guys could have just done that without doing these steps. However, with bigger numbers, it's sometimes better to do it this way because it always works. And you don't have to really guess and check except for up here when you're dealing with the numbers that multiply to 6 and add to 7. Alright, so if you guys feel comfortable already, try to do it on your own. If not, follow along for the next one. Alright, so I'm going to do it again. Multiply the first and last number, and I get negative 90. Okay, so I need two numbers that multiply to negative 90 that add to negative 1. And hopefully you guys see that that would be a 9 and a 10. If it's a negative 1, it has to be a negative 10x and a plus 9x. Then I bring down the minus 15. And some of you guys might say, well, how do I know what number to put here and here? What if I put 9 here or negative 10 here? It doesn't matter. It will work either way. Okay, so that's the good news about this. So we have 6x squared minus 10x plus 9x minus 15. And again, all we're doing here is we're turning the original statement into a statement we can factor by grouping. We're basically splitting this middle term into -10 and a +9, and now we can factor by grouping. So, for this first piece, I can take out a 2 and an x, and then I am left with 3x minus 5. And again, you know that these have to match at the end, like x plus 3 is in the last one, so you kind of want to see if you know you're doing it right if that happens. So I could pull a 3 out, and then when I pull a 3 out, I'm left with 3x minus 5. So sure enough, these pieces match. My final answer is going to be a 3x minus 5, and the outside pieces, 2x plus 3. And it is completely factored now. Okay? Alright, again, try, and before, let's talk about 3 real fast. Some of you guys might go, oh, those are big numbers. They are big numbers. However, you do not have to just start by doing Batman. The first thing you should always do, which I kind of neglected up there because I couldn't do anything with them anyway, you always should try to make it your life simpler by taking a GCF out. So, I can pull a 4 out of all these terms. So I'm going to do that first. So I'm going to pull a 4 out of there. When I pull a 4 out of there, I'm left with 3x squared minus 8x minus 3. Okay, this is a much nicer thing to do the splitting the middle term or Batman with. Okay, we do not, now we have better numbers. So now I'm going to do that in here. But you have to remember you have that 4 out there. If I'm asking you to factor, that's part of the thing that's being factored out. So, I multiply these down, I get a -9. I need things that multiply to -9 that add to -8. Well, that should be hopefully 9 and 1. It has to be a -9x and a plus 1x. I just split that middle term again. Bring down the -3. Bring down the 3x squared. Okay, now I have my grouping. I could pull out a 3x, and I'm left with x minus 3. Now let's color code it the same way. And then finally, I can over here only pull out a 1 again, but make sure you put that plus 1 if you're pulling out a 1, just so you know what you have. So your term's not just 3x and x minus 3. So factoring by grouping, I have 3x plus 1 and x minus 3. However, do not forget about the 4. This was pulled out originally. That goes down here in front. So the final factored answer of this would be 4 times the quantity 3x plus 1 times the quantity x minus 3. Again, this needs to match this original if you multiply it back out. If you forget the 4, it's not going to match the original problem. Alright, last problem, number 4. Again, anytime you want, pause it and try it on your own first, see if you can follow. Multiply the two first and last numbers. This one's a big one, -420. So you need things that multiply to -420 that add to 1. So you have to find the two numbers that are kind of next to each other that multiply to 420. And hopefully, if you use your calculator to figure that out, you get that 20 and 21 give you 420. So in order to have a positive 1 by adding, we have a minus 20x plus 21x. That, when added together, will get us our positive 1x. And then we have a minus 28. And we have a plus 15x squared. Okay? Now, again, we're just rewriting the first equation into this equation. The reason why I went right to Batman or splitting the middle term is that there is no number or x I can pull out of this. So there's no GCF, unlike 3 where we could pull a 4 out. Now I'm going to group, factor by grouping. I could take a 5 out and an x out of that, and I get 3x minus 4. Let me again color code it. So 3x minus 4 is left. And then I can pull, it looks like a 7 out of there. and you're left with 3x minus 4, which is, again, these are supposed to match. If they match, it works. So our final answer is 3x minus 4 and 5x plus 7. Alright, and those are all your notes for today. Okay, that just factoring with a number in front of the x squared. Again, first pull out numbers that you can, because sometimes there's problems that you think you have to do this on, but you can pull the number out and you don't have to. You can actually just reverse FOIL from yesterday's notes. So, I hope that makes sense. We will do a couple more of these in class tomorrow.